Greetings, dear professors and colleagues. My name is Mehmet Fatih. I am a master's student from Turkey. With this video, I will try to introduce you my thesis topic, discrete time implementation of harmonic control arrays method with a microcontroller. I am sorry for not attending due to the reasons I couldn't handle. I prepared this video presentation as short as I can for not to lose clarity. You can always contact with me if you wish to ask anything. First, I will introduce the harmonic control arrays method. Then, I will explain some key subjects of the method, the Fourier series and control systems. After it, I will make the description of the harmonic control arrays. In the end, I will show the results of the experiments about our method. The idea of the harmonic control arrays method is applying the control process not directly to the error signal, but applying the control operations to the different harmonic components of the control signal with different parameters one by one. Different harmonics can affect to other harmonics, or different control methods can be applied to different components even we didn't make any experiments on it. So, what do you mean with a harmonic? If our reference signal or distribution of the system is periodic, we can show our error and control signals with Fourier series representation. The term with A0 in the trigonometric form and C0 in the exponential form of the Fourier series representations are called the fundamental term. The term with C1 is called first harmonic, the term with C2 is called second harmonic, and so on. The process of representation the error signal with Fourier series representation is called harmonic disperser, and the reconstruction process of the control signal after control method is called harmonic assembler. In our experiments, we have chosen PID with zero derivative term for simplicity. Even we did use a single controller type with different parameters for different harmonic components, different controller types could be used. Let's start describing the harmonic control arrays method. The method consists of three main blocks. First, the error signal enters to the harmonic disperser block. After it, the dispersed harmonic components enter to the main block where the control process will be applied on them. After that, the scattered components of the control signal pull oneself together in harmonic assembler block. Finally, the control signal can be applied with a correct mapping. For harmonic dispersing process, discrete time equivalent of the Fourier series integral have been used. To shorten the operations of microcontrollers and this burden, the equation with a star beside it is proven. Since our microcontroller cannot make complex exponential calculus, the star equation is transformed to the last equation with Euler's formula, and real and complex terms are held in different memory addresses. In the main block, called harmonic control arrays block, control process will be applied to each harmonic component of the error signal with different parameters or even with different control methods. As told before, we use the PI controller with different parameters as seen in the figure. After the control operation, our control signal remains dissipated. To apply it to the blend, we must collect the different harmonic components of the control signal. The equations required for this inverse Fourier transform are given in the paper. We applied the algorithm with STM32F4 discovery board with an ARM microcontroller and sent the reference signal and PI parameters from a computer with MATLAB via serial port. The controller requires these signals, listens for them from serial port after powering up. When the required signals are received, the microcontroller begins to the harmonic control arrays method. It takes the error signal in a sliding buffer established, disperses it for sample by sample, applies the required control process to each harmonic component, assembles the control signals, and applies to the blend with linear mapping. This process comes through in an infinite loop. As we used electronic blends for our first experiments, we read the output signal with analog to digital converter and applied the control signal to the blend with digital to analog converter. Our saturation limits are defined by these units. At first, we tried the system with a sign reference on a linear filter circuit. The first order blend, the photograph of the system, and the results can be seen here. The PI parameters are found with trial and error method. After the sinusoidal reference, we got ahead with changing the reference signal to a 4 harmonics wave. Again, we found the parameters with trial and error method. One deficit of the method is here. When the number of the harmonics increases, it becomes harder to find different parameters. For this disadvantage, my advisor professor and I are thinking on a PID tuning method. We also achieved success with a nonlinear electronic plant with sinusoidal reference too. The results can be seen here. I apologize for the situation and badness of the presentation. Please forgive me. Feel free to send me email if you have any questions. Anyways, I thank you and to Professor Dries Mahdi for giving me this opportunity. Peace be upon you.